This is video 2A for the Year 11 Mathematical Methods course. In this video, we're going to be covering some example questions from solving quadratic equations under the topic of quadratics. The 9 questions we will be going through are now displayed on the screen, so I recommend that you attempt these questions before watching the rest of this video. Question 1. Using factorization, solve this quadratic equation. 6x squared take 7x is equal to 0. So we're starting off with the quadratic of 6x squared minus 7x is equal to 0. Now in this case here we've only got two terms and they've both got an x attached to them, so we can factorize out the x. And by doing so, we're then left with x, then in brackets, 6x minus 7 is equal to 0. And now by the null factor law, because x multiplied by this bracket is equal to 0, it tells us that either this thing has to equal to 0 or this thing has to equal to 0. So therefore, we can either say that x is equal to 0 or 6x minus 7 is equal to 0. And by solving for x, we're then left with x is equal to 7 over 6. So therefore, x is equal to 0 or 7 over 6. And now coming over to our graphics calculator to check this answer, we've come into our equation solver mode. And in this case, the coefficients that we're going to put in are 6, negative 7, and 0. And in this case, we get the answers of 7 over 6 and 0. Question 2. Using the sum and product rule, solve this quadratic equation. X squared plus 10x plus 21 is equal to 0. So we have the quadratic equation, x squared plus 10x plus 21 is equal to 0. And we are being told to use the sum and product rule to solve this equation. So, by the sum and product rule, we're looking for two numbers that when you add them together you get 10, and when you multiply them, you get 21. Now the factors of 21 are 1, 21, and then 7, 3. And you can probably see that if you add together 7 and 3, then you get the desired 10, which means that 7 and 3 are the two numbers that we're going to be working with. So therefore, we can factorize this quadratic equation into x plus 7, and then x plus 3 is equal to 0. And now, by the null factor law, because we have this thing multiplied by this thing is equal to 0, it tells us that either this one or this one has to equal to 0. So in other words, we either have x plus 7 is equal to 0, or we have x plus 3 is equal to 0. And so now by solving both of these for x, we get x is equal to negative 7, and we get x is equal to negative 3. So therefore, x can either equal negative 7 or negative 3. Coming over to our graphics calculator to check this answer, we've opened up our equation solver, and in this case the coefficients of our quadratic equation are 1, 10, and 21, which gets us answers of negative 3 and negative 7. Question 3. Using the sum and product rule, solve this quadratic equation. X squared plus 24 is equal to 10x. So we start off with the equation x squared plus 24 is equal to 10x. Now the first thing that you should notice about this particular equation here is that it is not in standard quadratic form. In other words, we do not have it in the format of ax squared plus bx plus c is equal to 0. So the first thing that we're going to do here is we're going to subtract 10x from both sides to make the right hand side equal to 0. What that then leaves us with is x squared take 10x plus 24 is equal to 0. And now this is something that we can absolutely work with. So we are now being told to solve this using the sum and product rule. In other words, we need to find two numbers that when you add them together, you get negative 10, and when you multiply them, you get 24. Well, the factors of 24 involve the following. 1, 24, 2 and 12, 3 and 8, and 6 and 4. Now, the only problem with these combinations here is that when we add these two numbers together, we need to get a negative answer, in this case, negative 10, which means that we're going to have to consider some of the negative factors as well. So in other words, we need to consider negative 1 and negative 24, negative 2 and negative 12, negative 3 and negative 8, and then negative 6 and negative 4. And so by looking through this list here, we can see that if we add together negative 6 and negative 4, then we get the desired negative 10. So that means that negative 6 and negative 4 are the two numbers that we want to work with. So therefore, we can now factorize this quadratic into the following. X take 6, x take 4 is equal to 0. And now by the null factor law, because we have this thing multiplied by this thing is equal to 0, we know that either this thing has to equal to 0 or this thing has to equal to 0. So in other words, x minus 6 must equal to 0 or x minus 4 must be equal to 0. And so then by solving both of these for x, we then get x is equal to 6 and x is equal to 4. So therefore, our solutions are x is equal to 4 and x is equal to 6. Coming over to our graphics calculator to double check this answer. Now in this case here, because we started with a quadratic in non-standard form, it means that when we put in these coefficients, we have to make sure that we put in the coefficients of this quadratic here, because this is the original quadratic in standard format. So in other words, our coefficients that we're going to put in are going to be 1, -10, and +24, in which case we get answers of 6 and 4. Question 4. By splitting the middle term, solve this quadratic equation. 6x squared plus 3x minus 3 is equal to 0. So we're starting off with the quadratic equation of 6x squared plus 3x minus 3 is equal to 0. Now in this case, we want to use the method of splitting the middle term. So that means that we need to find two numbers that when you add them together, you get this middle term here, which is 3. But then when you multiply them, you get the product of this number and this number. And the product of 6 and -3 is of course -18. So in this particular case, we need to find two numbers that when you add them together you get 3, and when you multiply them you get -18. So the easiest way to go about this is to start writing out the factors of -18. So of course you've got 1 and -18, -1 and +18. You've got 2 and -9, you've got -2 and +9. You've got 3 and -6, and you've got -3 and +6. And then if you look through all these combinations here, we see that if you add together 6 and -3, then you get the desired answer of 3. So the two numbers that we're going to consider in this case are -3 and +6, which means that we're now going to split this middle term of plus 3x into -3x and +6x. So let's write this out. So we've got the 6x squared stays as it is, and now we're splitting the middle term into minus 3x plus 6x, and then the constant term of -3 stays as it is. And now what we're going to do here is we're going to factorize pairs of terms. So factorizing 6x squared and minus 3x, we can pull out a 3 and we can pull out an x, in which case we're now left with 2x minus 1 in a bracket. And then from the final two terms, we can factorize out a 3, in which case we're now left with 2x take 1. And all this is equal to 0. Now in this particular case, we know that we've done the right thing because these two brackets are the exact same. So what that means now is that we can factorize out the brackets to the very front. So what we're now left with is 2x minus 1 out the front. Then I'm going to open up a second bracket. And then what I'm left with is this 3x. And then plus 3. And now by the null factor law, because we've got this thing multiplied by this thing is equal to 0, we know that either this thing has to equal to 0 or this thing has to equal to 0. So in other words, we have 2x minus 1 is equal to 0, or we have 3x plus 3 is equal to 0. And then by solving both of these for x, we have x is equal to 1/2, and then x is equal to -1. So therefore, x is equal to -1 and +1/2. And so now we're going to come over to our graphics calculator to double check our answer. The original quadratic in this case was the 6x squared plus 3x minus 3. So our coefficients that we're going to pop in are 6, 3, and -3. In which case we get answers of 1/2 and -1. Question 5. By splitting the middle term, solve this quadratic equation. 2x squared take 23 over 2x is equal to 35 over 2. So we are being asked to solve the quadratic equation of 2x squared take 23 over 2x is equal to 35 over 2. Alrighty, well first things first, this is of course not in the standard format for a quadratic equation, so we'll first of all have to subtract 35 over 2 from both sides to make the right hand side equal to 0. And in doing so, what we're then left with is 2x squared, take 23 over 2x, take 35 over 2, is equal to 0. And now we're being asked to use the process of splitting the middle term to solve for the values of x. Now, just a quick thing about this one, of course, in two of these terms, we've got a fraction over 2. Typically, whenever we're trying to solve quadratic equations, fractions make everything significantly harder, so it's in your best interest to try and remove those fractions as quickly as possible. And the way that we can do it in this case is we're going to multiply both sides of the equation by 2. Because then what we're going to be left with is 4x squared, take 23x, take 35, is equal to 0. And now this is something that we can solve a lot easier. So to use the process of splitting the middle term, we need to find two numbers that add to get this middle term here. So we need to find two numbers that add to negative 23. And then we need to find two numbers that when you multiply them together, they equal the product of these two numbers here. So in other words, they need to multiply to the product of 4 and negative 35, which is negative 140. Now this one here is a little bit more challenging, but we'll go through the exact same process that we've seen before to get to the two numbers that we're after. So we're going to first of all look at all the different factors of negative 140. So of course we've got negative 1 and 140, we've got 1 and negative 140, we've got 2 and negative 70, we've got negative 2 and positive 70, we've got 5 and negative 28, we've got negative 5 and positive 28, we've got negative 7 and positive 20, we've got 7 and negative 20, we have 10 and negative 14, and then finally we've got negative 10 and positive 14. So then if you start looking through all these different pairs of numbers, we can see that if we add together 5 and negative 28, then we get the desired negative 23. So 5 and negative 28 are the two numbers that we're going to work with in this question. Which means that we now have to split this middle term of negative 23x into 5x and then negative 28x. So in other words, we can now write this quadratic equation as 4x squared plus 5x, take 28x, take 35 is equal to 0. Where we've just split the negative 23x into this positive 5x and the negative 28x. And so now we want to start factorizing pairs of terms. So with these first two terms of 4x squared plus 5x, the most that we can factorize out is an x, in which case we're then just left with 4x plus 5. And then with these second two terms, the negative 28x and the negative 35, we can factorize out to negative 7, in which case we're then left with 4x plus 5, and all of this is of course equal to 0. Now we know that we're on the right track with this one here because these two brackets are the exact same, which means now we can factorize both of these brackets out to the very front. So then what we're left with is 4x plus 5, then we're going to open up a second bracket, and then what we're left with is this x, take 7. And so now, the null factor law tells us that because this thing multiplied by this thing is equal to 0, we know that either this thing has to equal to 0 or this thing has to equal to 0. So in other words, 4x plus 5 equals to 0 or x minus 7 is equal to 0. And so now by rearranging and solving for x, we're then left with x is equal to negative 5 over 4 and x is equal to positive 7. And so therefore, x is equal to negative 5 over 4 and 7. Now, if we want to come over to our graphics calculator to double check these answers, we need to make sure that when we pop in our coefficients, it's the coefficients of this quadratic equation here. Because again, originally we started in a non-standard quadratic form, and then this was our final rearranged version. So we need to make sure that we're popping in the coefficients from this particular equation here. So in other words, we're going to put in 4, negative 23, and negative 35. And what we have is 7 and negative 5 over 4. Question 6. By completing the square, solve this quadratic equation. X squared plus 5x take 7 is equal to 0. So, we're starting off with the quadratic equation of x squared plus 5x minus 7 is equal to 0, and we want to solve this by the method of completing the square. So, in order to complete the square, first thing we're going to do is move the constant term onto the other side of the equation. So to do that, we're going to add 7 to both sides, and then what we're left with is x squared plus 5x is equal to 7. Then, this is the really important part, we need to get the coefficient of x, which in this case is 5. We're going to divide it by 2. We're then going to square that and add it to both sides. In other words, we're now going to have x squared plus 5x. Then we're going to do add 5 over 2, because that's this number here. We're going to square that, and we're going to do that to both sides of the equation. And then with the left-hand side, we need to recall that if we have a quadratic in this particular format here, using perfect square factorization, this left-hand side can get factorized to x plus this part here, so in this case x plus 5 over 2, all squared. And then the right-hand side we can just simplify down as needed, so 7 plus 5 over 2 all squared, using your calculator, is 53 over 4. Then we need to take the square root of both sides of the equation. If we square root the left-hand side, then all we're left with is x plus 5 over 2. But then on the right-hand side, we get plus minus the square root of 53 over 4. And now with the right-hand side, we can split up the square root into two separate parts. So that will now be plus minus the square root of 53 over the square root of 4. And of course, the square root of 4 is just 2. So now the right-hand side is plus minus the square root of 53 over 2. And then finally, we want to get this x all by itself. So now I'm going to subtract 5 over 2 from both sides of the equation. And so then what we're left with is x is equal to negative 5 over 2 plus minus root 53 over 2. Now this here is a totally appropriate answer. However, I know that some people would prefer to write this as a solid fraction. So in other words, you can combine these two fractions with a denominator of 2 and then write it as negative 5 plus minus the square root of 53. And so here are your two solutions for x. We can't simplify this down any further because the square root of 53 is in fact an irrational number. So we can't do anything with that there. And now we want to come over to our graphics calculator to double check our answer. But of course we need to make sure that we're putting in the coefficients of the original question, which is with this quadratic equation up here. So in other words, we're going to put in 1, 5, and negative 7. And our two answers then are negative 5 plus root 53 over 2 and negative 5 take root 53 over 2. Question 7. By completing the square, solve this quadratic equation. 2x squared plus 2 is equal to negative 6x. So we have the quadratic equation of 2x squared plus 2 is equal to negative 6x. And the first thing that you should notice here is that this equation is not in the standard format for a quadratic equation. So to fix this, we're going to add 6x to both sides of the equation to make the right-hand side equal to 0. In which case, what we're now left with is 2x squared plus 6x plus 2 is equal to 0. Now, we are being asked to use the method of completing the square to solve this, which means, first of all, we need to divide through everything by the coefficient of x squared, which in this case is 2, so we're going to have to divide through everything by 2. And so then what we're left with is x squared plus 3x plus 1 is equal to 0. And remember, this should always be one of your very first steps whenever you're doing the method of completing the square, in that the coefficient of x squared always has to be 1. Alrighty, so what we're going to do from here is put the constant term on the other side of the equation, and we're going to do this by subtracting 1 from both sides of the equation. So then what we're left with is x squared plus 3x is equal to negative 1. And so now we're going to get the coefficient of x, which in this case is 3. We're going to divide that by 2, and we're going to square it and then add that to both sides of the equation. So what I mean by that is we're going to write x squared plus 3x. Then we're going to do add 3, because that's this number here. Then we're going to divide it by 2, and we're going to square that. And we're going to do that to both sides of the equation. And so now the left-hand side, because we've got a quadratic in this particular format here, it means that we can now write the left-hand side in the format of x plus this thing here. So in this case, x plus 3 over 2. And we're then going to square all of that. And now the right-hand side, we can just pop into our calculator to get 5 over 4. So now the next step is going to be to take the square root of both sides of the equation. If we take the square root of the left-hand side, then all we're left with is x plus 3 over 2. And then the right-hand side, we get plus minus the square root of 5 over 4. With the right-hand side, we can now split the square root up into two parts. So this is going to be plus minus the square root of 5 over the square root of 4. And the square root of 4 is of course just 2. So now we can write the right-hand side as plus minus the square root of 5 over 2. And now finally, to get the x all by itself, we're going to subtract 3 over 2 from both sides of the equation, in which case what we're then left with is x is equal to negative 3 over 2 plus minus the square root of 5 over 2. And this here is totally fine as a final answer. However, if you want to write this as one solid fraction, then we can write this as one big fraction over 2. And then on the top, we're just going to combine the numerators. So in other words, negative 3 plus minus the square root of 5. Now, in this particular case here, the square root of 5 is indeed an irrational number, which means that we cannot simplify this down any further. And so now if we want to use our graphics calculator to double check our answer, we want to make sure that when we're using the equation solver, that we pop in the coefficients from this quadratic equation here, because this here is a quadratic in the standard format, whereas our original equation was not in standard format. So we want to make sure that we're using these coefficients here. So if we come over to our equation solver, then the coefficients that we're going to put in are 1, 3, and 1, which gets us answers of negative 3 plus root 5 over 2 and negative 3 take root 5 over 2. Question 8. By completing the square, solve the general quadratic equation ax squared plus bx plus c is equal to 0, and thus derive the quadratic formula. Now, this question here is probably one of the trickiest and tedious questions that you will ever have to do when it comes to solving quadratic equations, but more specifically, using the method of completing the square. Because as you may recall I mentioned in the theory video, the really interesting thing about the quadratic formula is that it is essentially just the formula derived by solving the general quadratic equation using the method of completing the square. Now, does that make this question any easier? Absolutely not. It is quite a difficult one, but that's why we're going to go through this process very, very slowly. But I do want to make mention of the fact that if you are able to solve this one here, then you've officially done the hardest type of completing the square question there is, and you should be very, very proud of yourself. Now, without further ado, let's do this. So, we are starting off with ax squared plus bx plus c is equal to 0, where a, b, and c are just some arbitrary constants. Now, all we're going to do with this process here is we're going to use the exact same steps as we normally would in the method of completing the square. However, in this case, we just have to deal with constants rather than actual numbers. So if you may recall, step number 1 is to always make the coefficient of x squared equal to 1. In other words, in this case, we're going to have to divide through everything by a to get rid of that constant out the front. In which case, what we're then left with is x squared plus b over ax plus c over a is equal to 0. And then step number 2 is to move the constant term onto the other side of the equation. So that's this term here. So in order to do that, we have to subtract c over a from both sides of the equation. And so now what we're left with is x squared plus b over ax is equal to negative c over a. Then this is probably the trickiest part. If you may recall, the next step along the method of completing the square is to get the coefficient of x, which in this case is this one here. We then need to half it, square that result, and then add that to both sides of the equation. So let's do this very, very carefully. So the x squared stays as it is, so does this second term. But then we need to get the coefficient of x, which in this case is b over a, and then we need to divide that result by 2. So in other words, that will be b over 2a, and now we're going to square this. And we're going to do this to both sides of the equation. Next really, really important step, the left-hand side. Now that we've got it in this particular format here, if you may recall, this is now where we can use the method of perfect square factorization. And if you recall, when we have it in this particular format here, we can factorize this down to x plus, then whatever this thing here is, which is b over 2a, and then we square the entire thing. So that method of perfect square factorization applies here as well. Now the right-hand side, we have to try and simplify as much as we can. So what I'm going to do here is I'm going to write the first fraction as it appears, but then with the second fraction, I'm first of all going to apply this square to everything on the inside. So this will now be b squared over 4a squared. And if we really, really want to simplify this, I can try and combine these two fractions into a single fraction. The only problem right now is the fact that the denominators do not match. However, with the fraction of negative c over a, if I multiply the top and bottom by 4a, then what I'm left with is negative 4ac over 4a squared plus b squared over 4a squared. And this is really good for us now, considering the fact that we have two fractions with the exact same denominator. So now we can combine this into a fraction over 4a squared, and now if we combine the two numerators, we are then left with b squared minus 4ac. Alrighty, so what we can do now is square root both sides. So the left-hand side will now be x plus b over 2a, and then the right-hand side will be plus minus the square root of b squared minus 4ac all over 4a squared. And so from here, we can now split the right-hand side square root into two separate parts. So this part can now be rewritten as plus minus the square root of b squared minus 4ac over the square root of 4a squared. And we can now simplify this down even further. So the numerator can still stay as b squared minus 4ac, but then the denominator, the square root of 4a squared, is now equal to 2a. And so now to isolate the x on the left-hand side, we can now subtract away b over 2a from both sides, which then leaves us with x is equal to negative b over 2a plus minus the square root of b squared take 4ac over 2a. And so because these two fractions on the right-hand side have the exact same denominator, we can now combine them into a single fraction. In other words, we now have x is equal to negative b plus minus the square root of b squared take 4ac, all divided by 2a. And just like that, we have used the method of completing the square to derive the quadratic formula. Question 9. Use the quadratic formula to solve the following equation. 2x take 3 over x is equal to 4. So we're first of all starting off with 2x take 3 over x is equal to 4. Now we're being asked to use the quadratic formula to solve for this. However, as it currently appears, this equation is not in the form of a standard quadratic, mainly because we've got a 3 over x in this case. So that part there just doesn't work. So to get around this, what we're going to do is we're going to multiply through everything by x. In which case, what we'll then be left with is 2x squared take 3 is equal to 4x. And now even further, to get this in the format of a standard quadratic, I'm going to subtract 4x from both sides to make the right-hand side equal to 0. So then what we'll be left with is 2x squared take 4x take 3 is equal to 0. And now this is something that we can absolutely use the quadratic formula to solve for. So the first thing that we can do is identify our a, b, and c values. In this case, a will be equal to 2, b will be equal to negative 4, and c will be equal to negative 3. So let's start off with our quadratic formula. X is equal to negative b plus minus the square root of b squared take 4ac all divided by 2a. So now let's substitute in our values of a, b, and c into this formula very, very carefully. So we're now going to have x is equal to negative b, which will now be negative 4, plus minus the square root of b squared, so that will be negative 4 all squared, take 4 lots of a, which is 2, multiplied by c, which is negative 3, all divided by 2a, so that'll be 2 lots of 2. Simplifying all this, we're then left with 4 plus minus the square root of 40 divided by 4. And we can now simplify this even further. We're going to now do 4 plus minus, and now the square root of 40 can get reduced down to 2 root 10 divided by 4. And so then if we divide through the top and bottom by 2, what we're then left with is 2 plus minus root 10 over 2. So in other words, the solutions to our equation are x is equal to 2 plus minus the square root of 10, all divided by 2. And we can't simplify this down even further because the square root of 10 is indeed an irrational number. Now, let's use our graphics calculator to double check this answer. Now, because the original equation was not in the form of a quadratic, we need to make sure that when we use our equation solver, we use the coefficients of this equation here, considering the fact that we started with this equation and then turned it into this quadratic equation here. So if we come over to our equation solver, the coefficients that we'll use are 2, negative 4, and negative 3. And then the solutions that we get are 2 plus the square root of 10 divided by 2, and 2 take the square root of 10, all divided by 2.